and I just need to fix the query parameters that I'm passing in to this method. So we don't have a page or the sort field. The page size is now a limit, and we can pass in the respective limit value. I'll do the same above and get rid of the sort, and we have to take care of the cursor. In case of the next page, I'm just going to pass in the next cursor value. I have a next page if the cursor value is not null or empty, so I can pass in the next cursor, or to be even more restrictive, I can say is not null or white space. And in case of the self-referencing link, the cursor value is going to be null, or I can just pass in what I have in the current query parameters. In case of the self-referencing link, I'm just going to pass in the current value of the cursor parameter. So now if I go back to my controller, this method is going to be correctly called, and it will set the hypermedia link in my response. And now we get to the most important part, and that's actually applying a cursor if it's present in the API request. So I'm going to drop in a piece of code here, and then let's discuss what is happening here, because this is critical for understanding how cursor pagination works. So I'm checking if the query cursor isn't a null or empty string, and if it's not, I'm going to say entry cursor DTO and try to decode this value. This will give me back my DTO object, which if it's not null, then I can perform the cursor pagination operation. And what this comes down to is finding the values in the database depending on the sort order that you are using. Because we are sorting by the descending value of the date, we want to find all the values in our database where the date of the entry is less than the date value on the cursor. But we could also run into a situation where we should return records that have the same value as the current date. And this is decided by our second sort column, the ID value. So in this case, the dates are going to be equal, and if they are equal, then we want to return those records where the ID value is less than or equal to the ID value in the cursor. So I know this is a lot to comprehend, but just think about how we are sorting the values in the response, and based on the sort order, we take the first 10 records, and we also grab the 11th one, which represents our cursor. The next time we are fetching the entries from the database, we are pointing directly to that 11th record, and we are returning any values from that record in the same sort order. Let's go ahead and start the application, and I'll demonstrate how this works. I'll send a GET request to the entry's cursor endpoint, and I'll set the limit value to 100. I have slightly less than 200 entries in the database, so this should result in us seeing at most 2 pages. Let me send the first request. We get a response back that contains my items. This is working fine, but if we take a look at the hypermedia links, you can see that the self-referencing link has a limit without a cursor, and if I scroll down, here's my next page link, and it contains the limit value and the cursor. The cursor is completely opaque. You have no idea what it represents looking at it. Of course, you could decode it and then see the ID value and the date, but the client application shouldn't really care about this. Now I can send this request, and I'll get back my next page of results. And if you take a look at the hypermedia links here, the self-referencing link is correctly set, but there is no next page link because we have reached the end of the results. If we take a look at our distributed traces and go into the specific trace for the GET request to the entry's cursor endpoint, we can observe the SQL statement that is sent to our database when we have a cursor. So let's examine what we have here. Here's the select statement from the entries table, and if you take a look at the where statement, you'll see there's a filter to find all the records that belong to the current user, and then we have an additional filter that is checking that the date value is less than the cursor date, or that it's equal to the cursor date, and the ID value is less than or equal to the cursor ID, which represents the last record that we return from the database. So this is what I meant when I said that the cursor represents a kind of an index pointing to a specific row from which you want to take the next set of results. Notice that we also have just the limit statement here, whereas with offset pagination we had offset and then limit. So in that regard, cursor pagination is more efficient because it's going to find the specific row that represents your next result set and just do a limit operation from that point. If you also define an index on the date column in descending order and the ID column in descending order, you're going to get a covering index for this query, and then this is going to be blazing fast. So that is why cursor pagination is so interesting. Now, where is something like this appropriate? Note the sort order here. We want to always get the most fresh results first, and you will typically use this for some sort of screen on the user interface that only cares about the latest results. Our page representing the entries of the current user is a good example of that, and that's where I'm going to integrate this new endpoint. However, the drawback with this approach is that you have to respect the sort order and it has to be unique. So if you need support for arbitrary sorting in your API endpoint, then you shouldn't be considering cursor pagination. In order to support this functionality in the client application, I made a couple of changes. First, I added a new method in the useEntries hook that is going to call my new entries cursor endpoint. Of course, it's going to respect the hypermedia link if it's provided as an argument, otherwise it's just going to specify a limit value, and this will kick off the first request. Inside of the entries page component, which is what is loading the entries from the REST API, I'm calling this new endpoint, getEntriesCursor, and I'm specifying the limit value of 50, or the hypermedia link if it's provided. The only other change I needed to make this work is not override the result items when I get back the response. Instead, I append them to the existing collection of items so that I render them on the screen in something that resembles an infinite scroll. And also at the end, where I had the next page link, I renamed it to more closely represent what it's actually doing. The previous page link will simply not be loaded because there is no previous page hypermedia link, so I didn't have to do anything there. And finally, if I open up the user interface and open the network tab, and scroll to the bottom, you can see I have a load more button. If I press this button, it's going to send a request to our cursor endpoint with the cursor representing the next page. Because I have around 200 entries, I should have 4 pages, which means we should see 2 additional requests. So let's press load more. We get 1 more request. And if I press load more, there is no next page link, which I can also confirm from the response. So let me look at the response. And if I scroll this down all the way to the hypermedia links, you will see that there is no next page link in this response. However, if I look at the next to last response, you can see that I have a next page link right here. Also, if we take a quick look at the dates here, you can see that they are sorted by the date. At the top, I see the latest date, which is February 13th when I'm recording this video. Now let's just test out if this is working by creating an entry that is very much in the past. The last one I have here is on January 13th. So let me go back to the top. I'll press create entry. Let's choose daily coding as my habit. I'll use a value of 1. The nodes can remain empty. For the date, I'm going to choose something in 2024. And then let's create this entry. And now if I keep loading my entries, even though this entry that I just created has a new creation ID, which should place it at the top of the results, I expect it to be the last record here. And you can see the value here, February 13th, 2024. This is the record that I just created. But if I were to sort them by the ID field, then this value would be on top because its identifier is greater. So I did this just to confirm that cursor pagination will work as expected, even when you insert records that kind of belong to the last page of results. So that's how you can implement cursor pagination in a REST API. What we didn't implement here is fetching the previous page. I'll leave that as a homework assignment for you if you want to explore this topic further. Another improvement we could make is make the client application instantly load the next page of entries when we have scrolled enough near the bottom of the page. This could kick off another API request instead of having to click the load more button. I think cursor pagination is definitely an interesting approach, and it's important when you want to build a REST API that should return the latest results at the top, and you typically only care about the latest results. The further down you go with the list of pages, the less relevant the results become. With this, we're also going to wrap up the topic of pagination. We covered both offset and cursor-based pagination and explained the differences between the two and when using one or the other is more appropriate. In our next lesson, I'm going to introduce you to Refit, which is a library that allows you to automatically generate HTTP clients for communicating with external APIs. So let's proceed to our next lesson and see how we're going to use Refit.